Let's try understanding what exactly the statement says, and then you have to memorize it. So first let's cover the understanding part. So here postulate 3 says that whenever you have to draw a circle, you can take any radius, or you can also take any center. So we can take any radius. Let's say taking the radius as a 2 centimeter and taking the center over here and then drawing a circle. Or maybe if you want to draw a bigger circle, you can take radius maybe as a 8 centimeter, and here you can maintain the center and then you can draw a circle. So we can draw a circle with any radius, any center. Like, that much explanation is not required at all, because the statement is very logical. Yes, we can draw a circle with any radius and any center, right? If I will say that there is a line, and the name of the line is this, PQ is a straight line, and maintaining the center at a point Q. Please draw a circle of radius 2 centimeter. So you will be able to draw. You will be able to draw. Yes or no?
Yes, ma'am.
Okay. Similarly, if I will say that now take the center as a P and take the radius as a whatever 7 centimeter, 6 centimeter, and draw a circle. So you will place your compass at a point P. Whatever radius I have mentioned, that much measurement you will take in your compass with the help of the scale, and then you will draw a circle. Right? Right?
Yes, ma'am.
Okay, that's what the statement says, that we can draw a circle anywhere with any radius. Yes, we can draw a circle anywhere with any radius. Okay, so this is postulate number 3, which says that a circle can be drawn with any center and any radius. So those two postulates you have already learned. Just add it over there, that a circle can be drawn with any radius and any center. Okay, or any center and any radius. However, you are saying it's the same thing.
Okay.
Let's proceed. Now, you tell me. I am giving you two options. The first option is, at first you are going to tell me 1, 2, 3, or let's discuss 4 also, and then you are going to tell me 1, 2, 3, 4.
Let's discuss 4.
Let's discuss 4 also,
Yes,
because 3 is very basic. A circle can be drawn with any radius, any center. A circle can be drawn with any center, any radius.
yes, ma'am. All
Okay.
right angles are equal to 1 another.
So next one is all. Postulate number 4. All right angles are equal to one another. Postulate 4 says that all right angles are equal to one another. Now, right angle means what? Right angle means 90 degree.
Yes, ma'am.
Okay. So if you are having a right angle over here, wait. If you are having a right angle over here, let's say this is A, B, C, D. So you can see we have maintained right angle. At angle B is right angle, and the proper name is angle ABD is right angle. Okay. And if you are having a right angle like this, here the name MNO. Okay. Here MNO is right angle. So here also it's 90 degree. Here also it's 90 degree. Of course, both the angles are equal with each other. Right?
Yes, ma'am.
Okay, that's what the statement says, that all right angle are equal to one another. Yes, right angle means 90 degree, and if two angles are same 90 degree, 90 degree, of course, both the angle are equal to one another. So postulate number 3 and postulate number 4, it's not that it's Very simple. The third one is a circle can be drawn with any center, any radius. All right angle are equal to one another. Now all four postulate you have to tell me in one go. In one go. Okay? Please tell me one by one.
Can I see?
Yeah, sure.
A straight line may be drawn from any point to to other point. Given to distance point, there is a unique line that passes through them. A circle can be drawn with any radius and any and center. And
It is just you
uh, uh,
so terminated line can be produced indefinitely. That
yes, ma'am. A terminated can yes, ma'am. I forgot the second. A terminated line can be defined can be produced indefinitely, and a circle can be drawn with any radius and any center. All right angles are equal to one another.
yeah, perfect. Okay. Now Ifra.
Postulate 1 says that a straight line may be drawn from any one point to any other point. Its explanation is given two distinct points, there is a unique line that passes through them. Postulate 2 says that a terminated line can be produced indefinitely. Postulate 3 says that a circle can be drawn with any center and any radius. Postulate 4 says that all right angles are equal to 1.
Uh, Sarah, will you be able to tell me the third and the fourth one?
Yes, ma'am.
Yes.
A circle can be drawn without any center and radius. All right
Without,
angles equal to
with,
one
and
another.
set. You said without, or I heard without.
Huh?
A circle can be drawn with you said, right?
Yeah.
Yeah, it's perfect. Yes, Sazia.
Yes, ma'am. Postulate number one is that a straight line can be drawn from one point to another point. Postulate number two is that a terminated line can be drawn indefinitely. Postulate number three is a circle can be drawn from any radius, and postulate number four is all
Any
right
radius,
angles are
any
equal.
center.
Yes, ma'am.
Yes.
With any center.
Okay, perfect. Now, Umaisha.
Yes, ma'am. A straight line may be drawn from any one point to any other point. Given two distinct lines, there is a unique line that passes through them. A
Distinct point.
distinct point that passes through them. Has given two distinct points, there is a unique line that passes through them. A terminated line can be produced indefinitely. A circle can be drawn with any center and any radius. All right angles are equal to one another.
Yes. Now the last postulate, which is very important. Let me write it.
A straight line.
The first straight
For
line.
us, we have till postulate 4.
What? What?
Ma'am, actually, like for us, it is just in postulate number 4.
Okay, for you it's just in postulate number four. Okay, no worries. I'm explaining it. I will not ask you. I will not ask anyone because you need you need to memorize it properly. Here, the statement is quite big, so I'll give it as a homework. Okay, so you
Ma'am, I
don't
have
have to
understood.
memorize if it is not there in your syllabus. Everyone, yes, Tejas, is it there in your syllabus?
Yes, ma'am, and I have learned this too.
Okay, you have learned this too very well. Farhan, if Ifra, you said it's not there. Rumaisha, Sara, Sazia, it's there, right?
Yes, ma'am, it's there.
Yes, ma'am. It's there.
Okay, let's continue. Okay, Ifra, you just need to understand it. Okay, even if it's not there, if you will understand, it will help you in future. If a straight line falling
falling on two straight
on two straight line
makes the interior line
make the interior
on the same side.
same side taken together less than two
Two right
right
angles. Then the two straight lines.
is reduced.
Definitely meet on that the same side. Which the sum of angles is less than two right.
Yes, the sum of angles is less than two right
Angles.
okay, you can see it's huge. Okay, but first you need to understand it. Let's try understanding what this statement says. Okay. If a straight line, I'm reading it from the very beginning. If a straight line, if a straight line, if a straight line, let's draw a straight line. But how we will draw? For that, let's read the next part also. So if a straight line falling on two straight lines, if a straight line falling on two straight lines, there are two straight lines and one straight line is falling on both of them. Okay, if a straight line, this is a straight line which the statement mentioned at first. If a straight line, it is talking about this straight line, this, let's name it L. If a straight line, let's say it's L, falling on two straight line, so we have drawn it in such a way that this straight line L is falling on P and Q. Is it clear so far? There is a straight line L which is falling on to other straight line. Clear?
Yes, ma'am.
Yes.
Okay. Makes the interior angle on the same side of it. Again, let's read it. If a straight line falling on two straight line, make the interior angle on the same side of it. Make the interior angle on the same side of it. It means on the same side of this straight line. Okay, on the same side. Interior angle, that means inside angle on the same side of it. On the same side of it. It means on the same side of this straight line which was mentioned at first in the statement. So if a straight line falling on two straight line makes interior angle on same side of it, makes interior angle, why I have marked only this, other two are also interior angle, which two, this and this, interior angle on the same side of it, it means the straight line L. Interior angle on the same side of L, interior angle on same side of L. That's what the statement says, that if a straight line falling on two straight line, now the straight line is making the interior angle on same side of it, taken together, the interior angles which we can see over here, if taken together, see, taken together less than 2 right angle. If we will take this interior angle, suppose this is x, this is y, if taken together, that means x plus y, or maybe that is, or maybe that is z, this one is t, taken together means z plus t. Okay, now focus here, clearly it is written that less than 2 right angle. Right angle means, right angle means, who will say right angle
90
means?
degree.
90 degree. And 2 right angle means, 2
Right.
right angle means 2 times right
180.
angle.
Yes, 180.
2 right angle means 90 plus 90. Okay, which is 180. Yes, Tejas. 2 right angle means, this 2 right angle means 180 degree. Okay, now let's read it in a, like from the very beginning till here. If a straight line falling on two straight line makes the interior angle on same side of it, taken together, is less than 2 right angle, is less than 2 right angle. If it is less than 2 right angle, that means 180 degree, or maybe if it is less than 2 right angle, that is 180 degree, then what, let's read it. So far, are you getting it? What does it
Yes, ma'am.
says
All clear.
here,
Yes, ma'am.
everyone? Okay,
Yes,
then
ma'am.
what?
Yes.
Then the two straight lines, if
समझ में आ
produced,
रहा?
yes,
हाँ.
do you want to say anything, Umaisha?
No, ma'am.
It says that then the two straight line, if produced indefinitely, then the two straight line, which is straight line? This two straight line which we have taken initially, P and Q, then the two straight line produced indefinitely, if you will produce them till infinity, what you will find? Meet on that side on which the sum of angle is less than 2 right. Now let me explain it completely. It says that if a straight line falling on two straight line makes interior angle on same side of it, combined together, added together, taken together, whatever you say, taken together, if it is less than 2 right angle, if it is less than 2 right angle, then if you will produce it till infinity, then these two lines are going to meet with each other. It will meet with each other. If sum of the interior angle on the same side is less than 180 degree, then this two line which you have drawn as a P and Q, this two is going to intersect each other. If not now, then you will produce indefinitely. You will produce it till infinity. You will find that somewhere it is intersecting each other. Now let me help you recalling the concept that there was a concept in parallel lines and angles chapter, that if we are having two parallel lines and if there is a transversal, then sum of interior angle on the same side is 180 degree. Yes or no?
Yes, ma'am. Yes, ma'am.
Okay. So it is 180 degree. Then this two line M and N must be parallel with each other. If sum of the interior angle on the same side is 180 degree, then these two lines are parallel. And Euclid is giving the same statement. If it is less than 180, then this two line will not be parallel. It is going to intersect with each other. Yes or no? Are you able to
Yes, ma'am.
relate with that concept? It was parallel over there
Yes,
when
ma'am.
the sum of interior angle is equals to 180. And here Euclid said that if it is smaller than 180, then of course our line is going to meet with each other. Now what about the last statement? Why it is so confusing? It's not confusing. Read it carefully, all the red underlined part, that it will, if produce indefinitely, the red underlined part, this one from if. Okay, let's read it. If produce indefinitely, meet on that side. It will meet on that side only where you have got the sum of interior angle less than 180. Okay, suppose this side x plus y is equals to 180 and that side z plus t is smaller than 180. Then in this side, if you will produce, it will just intersect each other, but not on the other side. Getting it? Getting it?
Yes, ma'am.
Okay,
Yes,
that's
ma'am.
Yes,
why
ma'am.
there is a elaboration, there is a clarification towards the last, that if produce indefinitely meet with each other, that much is not written. It is written clearly. Okay, if produce indefinitely, meet on that side on which the sum of the angle is less than two right angles. Let's combine it. If a straight line, falling on two straight line makes the interior angle on the same side of it taken together is less than two right angle, that means 180 degree, then what will happen? Then the two straight line, then this two straight line, if produced indefinitely, meet on that side on which the sum of the angle is less than 2 right angle. Is it clear to all of you?
Yes,
Yes,
ma'am.
ma'am.
Okay,
Yes, ma'am.
so yeah, this is how, like, if it is smaller than 180, the distance between two lines will get smaller, and it eventually is going to meet. If it is, what about the case if it is 180, both the line will maintain the same distance. The distance between two lines will be same. If it is more than 180, then randomly anything can be distance. It will meet or not meet, we don't know. But the distance will keep on increasing, and it depends. Like, it depends that it will go consistently, or after that it is going to meet, or what, like randomly the line will go. Okay, it will not maintain same distance. Randomly the line will go. And yeah, that time also it will not be parallel. Okay,
Yes.
If you are thinking about that scenario, what if the sum of the interior angle is more than 180? More than 180, then we can say the line will go like that and still it is not parallel, right?
Yes, ma'am.
So this is the postulate number 5. A straight line falling onto a straight line makes interior angle on same side taken together is less than 2 right angle, then the two straight line is produced indefinitely. Meet on that side on which the sum of angle is less than 2 right. Is it crystal clear the explanation part to everyone?
Yes,
Don't
ma'am.
worry,
It
I
is
am
clear.
not.
Yes, ma'am.
Yes, ma'am.
Yes, to other students, is it crystal clear?
Yes,
Yes,
ma'am.
ma'am.
Yes. So this was the last postulate we had. Now let me check few questions we can discuss over here.
Ma'am, after this chapter, which chapter we gonna do?
Coordinate geometry we have not discussed so far. Lines and angles also I want to discuss with you all. So I think
Okay, ma'am.
from these two chapters, anything I will start and then finish it.
Okay.
Okay. Let's solve one question. Question is proof that
Ma'am, there is one
equilibrium
theorem also.
is theorem.
Ma'am, theorem 5.1. Two distant lines cannot have more than one point in common.
Yes, prove that an equilateral triangle can be constructed on any given line segment.
Ma'am,
Yes.
ma'am, there is also one theorem.
Yeah, we'll be discussing. I'm coming to that. Tejas.
Okay, okay.
Okay. Let's discuss this question. So it says that prove that an equilateral triangle can be constructed on any given line segment. Okay,
Ma'am,
we
here,
have to prove it. Yes.
ma'am, here you can we can use postulate 3.
Postulate number 3. Yeah. Yes, we will be using that. Okay. Yes, we will be using postulate number 3. What? How we will prove Tejas? If you very well you have identified it correctly. Like how will we be using that? Please tell.
Just let me figure it out.
You are going to think about it.
Yes, ma'am.
I'm coming to the explanation of this one. Meanwhile, if you can think this, yes, he said it correctly that we are supposed to use postulate 3. A circle can be drawn with any center and any radius.
Ma'am, you can draw circle with point E, and then as the center AB is the radius, like
Yeah. What we will do over here at first to prove it, what we will do at first, we will construct a straight line, PQ, AB, whatever you want to name it. Any random length I have taken. Okay. What we want to do, we have to draw an equilateral triangle over here. Okay. Equilateral triangle we are supposed to draw over here. Who has unmuted himself? Yes. Yes. So equilateral triangle we are supposed to draw over here. We will be using postulate number 3. Okay. What we will say that AB we have drawn. Let's say AB we have drawn of 5 centimeter length we have taken, and we have drawn a straight line, that is AB. Now maintaining the center at a point A, just press the needle of the compass at a point A, and we need to take the radius as a complete AB, and then we will draw an arc over it. Okay, and again arc you draw, or a circle you draw, it's completely your choice. You can draw a circle as well. You can draw a circle as well. So just a second, let me then explain you with smaller measurement. Just a second, then it will be more clear. So we are drawing a straight line AB, and I'm telling you to take a smaller, just a smaller measurement, that is 3 centimeters. Now keeping the needle of the compass at a point A, and AB we will take in the whole compass, we will take the measurement AB, that means radius we are going to maintain AB, and we will draw a circle like this. Is it crystal clear so far? Which point is the center and which point is the, what exactly is the radius? Step 1 is,
Yes, ma'am.
draw AB of AB is equals to 3 centimeter. Okay. Step 2. Step 2. Taking A as a center and AB as radius, circle is drawn. Now keep in mind, if you are saying that A is a center, that means your compass needle you are pressing at A, and then you are drawing a circle. Now step 3 will be taking point B as center and BA as radius, drawing another circle. Let's draw now. This time we are going to take the center at B and radius as BA. Now don't get confused, BA as a radius, and previous case we have taken AB as a radius. Both time we are taking the same radius, yes or no? Even if we will change the
Yes,
name.
ma'am.
First time we have taken radius as a AB. Now we are going to take radius as a BA. It's the same thing. Radius is same. Yes or no? Yes or no?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes.
Okay, if you will draw a circle, your circle will look like this. Keeping in mind that this time point B is the center. Okay, something like this your circle will look like. Now what you will do, you will mark it as a C, and you will join them. You will join A with C. You will join A with C and B with C. Can you check it? This AC is nothing but just another radius. of green
Yes,
color
ma'am.
circle? Can
Yes.
you see it? Of this green colored circle, AC is the radius, yes or no?
Yes, ma'am.
And BC is also the radius of this green colored circle. Can you see it? Yes or no?
Yes, ma'am.
Yes, everyone. Can you see it?
Yes, ma'am.
Now, can we say ABC is just a equilateral triangle because we have drawn AB. Now we have maintained, we have taken the radius as a AB and have drawn a circle. So this also looks like a radius only. This also looks like a radius only. And we have constructed an equilateral triangle. Now, which postulate we are using? A circle can be drawn with any center and any radius, and that's what we are using over here. With any center, any radius, we are just keep on drawing the circles, and we ended up getting our equilateral triangle with the help of the postulate number 3. Yes or no?
Yes, ma'am.
Yes, ma'am.
Is it crystal clear to all of you?
Yes.
Yes, ma'am.
Yes.
So this is how we will prove it. Here you have to mention by using postulate 3 and explain postulate 3 that a circle can be drawn
From many radius and center.
with any radius, any center, and any center, whatever, any center and any radius. Hence, triangle ABC is an equilateral
Right.
triangle. Okay, and we are done. This is how we need to prove it by doing the construction. Got it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes. Tejas, you say you was talking about theorem, right?
Yes, ma'am.
Which theorem, Tejas?
Ma'am, ma'am, theorem
Can't,
5.1.
in your book it is mentioned.
Yes, ma'am. Two distance lines cannot have more than one point in common.
Let's see what exactly the theorem is trying. Cannot have more than one point in common. Let's see what the statement says. Okay, two distinct lines cannot have more than one point in common. Okay, we will try understanding the statement. So the statement says that two distinct lines, two different lines have cannot it cannot have more than one point in common. That means the chances are when you will produce it, both are going to intersect each other, or maybe both will never ever intersect each other. So this one is called intersecting line, and this one is called parallel lines. Okay, so
Okay.
when we are having two distinct lines, there are two possibilities. Either both the lines are going to intersect each other, or or both line will not intersect each other. Okay, cannot have more than one point in common. That means maximum 1 point of intersection will be there. If I will say I can have, or what can we say? If you are saying maximum you need 2 oranges, that means 2 is okay, 1 is also okay, and no orange is also okay. Maximum means that only mathematically, that if we are saying that at most or maximum 5, maximum 6, or maximum 90 marks is required, that means less than 90 is okay. Okay, max to max 90 the person needs. That's what this terminology maximum, or this in there is a concept. Let me take a proper example so that it will make good sense to you. Just a sec. Yeah, so the example can be in real life scenario, that maximum a person can memorize 2 pages or 10 question answer from history. There, like suppose from the from history you can memorize maximum 10 question answer in one go. Maximum 10. That means 9 is okay to you, right? Easily you can learn 9. 8 question answer also you can learn. 7 is also okay to you. 6 is also okay to you. 5 is also okay to you. And if there is no assignment, you are relaxed, because max to max you can learn 10,
Yes,
right?
ma'am.
That is your capacity, right?
Yes.
So whenever it says that cannot have more than 1 point, that means maximum 1 point. It it cannot have more than 1 point in common. That means maximum 1 point of intersection is there. Why? Because you think about it, when you are drawing two lines, chances are both will intersect each other somewhere at one point, or both
Yes,
will
ma'am.
never ever intersect each other. Now if you are thinking that both will again intersect each other, no, that will never ever happen, because this is curve, this is not line. We are talking about a straight line. Getting it?
Yes,
Yes, ma'am.
got it.
So when you are having two straight lines, chances are both will intersect each other maximum at one point, or will never ever intersect each other, never intersect each other. And that such line is called parallel. So that's what the theorem says. Two distinct line, that means two different line, cannot have more than 1 point in common. Two different line cannot have 1 point, more than 1 point in common. Okay, max to max
Okay,
one
ma'am.
point it can have,